hustling, 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 hustling. Every day I'm hustling, every day I'm hustling, every day I'm hustling, every day.
So I don't feel like pizza today. I want a cookie. How much are cookies?
They're 50 cents. But if you go to that guy over there, he can give you a cookie. Tell him that Katie sent you.
Okay.
Hustling, 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 hustling.
Hey,
That was good.
I heard you could hook me up with a good price.
Yeah, you know, I got whatever you need.
I got $13, so I'll buy as many as I can get.
Alright, well.
In order to solve this problem, we will use a step function. I bet you're wondering what that is. Well, a step function is a graph that resembles a series of steps. The function f, such that for every real number x, f of x, is the greatest integer less than or equal to x. In order to solve this, we will draw a graph. To begin our graph, we will begin by drawing the x-axis. After drawing the x, we will shortly follow with the y. We will then label 0 on our graph. This is our beginning point of reference. Next, we will label the y-axis. This demonstrates how much money we will spend on cookies. For demonstrational purposes, I am listing up to 4. Now we can finally label the x-axis. This will demonstrate how many cookies we can buy. For demonstrational purposes, I am only listing to 2. Now we can finally draw our graph. Now you'll notice that the line is actually straight instead of a curve. This is because we can't afford a cookie until we have 35 cents. Cutting short at 34 cents, we will draw a blank circle at 35. On our next line, we will have a filled-in circle at 35. This fills in the placeholder we had on our lower line. We will then continue a line till 70, where yet again we will place a blank circle. We cannot afford another cookie till we have 70 cents. Now looking at the graph, you can see why it gets the name step function. Your graph begins to look more and more like a staircase with each line you place. Continuing at this rate, we want to know how many cookies we can afford with $13. To solve this problem, we will use this equation. The weird parentheses you see around the fraction is what's known as the floor function. It's basically another way of saying step function. So at this rate, how many cookies can we get with $13? So did you guys get that?
No?
It's 37 cookies.
Oh my goodness, Spanish is so hard.
Yeah, well, if you have Miss Horner, just make sure that you keep everything organized, and she really appreciates that, and it kind of makes the class a lot easier.
And what happened to your locker?
Oh, well, see, what happened is,
Awkward moment. She went over with a cookie. Senor. Oh, rojo.
you got jokes, we have the blooper reel. All right,
Starring Jake.
Yeah.